So let's start about the combustion analysis. And what is this combustion analysis? If you remember, the in the previous slide we have shown that empirical formula determination was given by three method. If you know the gram of each element in the compound. Second method was if we know the percentage composition of each element present in the compound. And third method was given the combustion analysis data for the compound. So now here we are going to study about this combustion analysis. So what is the combustion analysis? Usually combustion analysis was performed for the organic compounds or molecular compound which have mostly carbon, hydrogen and oxygen. And this figure shows here mass gained in each absorbent. So what happened, we put one sample in the furnace and then pass the oxygen gas, and then it burned carbon and hydrogen and oxygen. So basically oxygen doesn't burn, but carbon burn into carbon dioxide and water burn, and then water produces by from the sample, and that have two absorbents for water separate and carbon dioxide separate. So once we will know the how much carbon dioxide was absorbed and how much water was absorbed, we calculate from back. For the mass of the carbon was determined from the mass of the CO2 produced, and mass of hydrogen is determined from the mass of the water produced, and mass of oxygen was determined by the difference of the mass of the compound used and the total mass of carbon and hydrogen. So if you know the percentage of this one carbon, and if you know the percentage of hydrogen, and if there is only carbon, hydrogen and oxygen, then we can subtract the percentage of carbon and hydrogen by 100, so that will be equal to percentage of oxygen. So the mass of oxygen in the compound cannot be determined by from CO2 or water, because oxygen is adding during the combustion. So since we are adding carbon dioxide oxygen gas, that is why we cannot calculate how much oxygen is coming. So we indirectly calculate for oxygen by subtracting the amount or percentage of carbon and hydrogen from carbon dioxide and water, and then minus it by 100. So this is the significance of combustion analysis. And here we will see, if we know the combustion analysis, usually see this is the pathway to calculate the mass of the carbon is determined from the mass of CO2 produced. So let's see how we calculate the mass of carbon dioxide gas using mass of carbon using carbon dioxide gas. So mass of the carbon dioxide produced, when we calculate from the combustion analysis, that was converted into mole of carbon dioxide gas produced using this conversion factor, molar mass of CO2, which is 44.0 gram per mole. And once we know the mole of carbon dioxide gas produced, we convert into mole of carbon in the original sample, because 1 mole of carbon dioxide gas is will produce only 1 mole of carbon. And once we know the number of moles, then we can calculate the mass in the gram quantity of carbon using this molar mass conversion, 12 gram per mole. And same way, if we this is the pathway for mass of hydrogen is determined from the mass of water produced. So if mass of water is produced is x gram, then that using that mass we convert into mole of water using molar conversion of water, molar mass of 18.0 gram per mole. And once we know the mole of water produced, then you can see 1 mole of water will produce 2 moles of hydrogen atom. So whatever the one number of water will come, that will produce twice of hydrogen. And then from once we know the total number of hydrogen, then we convert these moles into mass in the gram using this molar mass conversion, which is 1.01 gram per mole. So this is the way we calculate, and once follow the path for determination of carbon and hydrogen using combustion analysis. Here is another thing, that how we use the quantitative information from the balance equation. So if we know the any balance equation, for an example, 2 hydrogen gas when react with 2 oxygen gas produces 2 water molecule. So this balance equation is giving some quantitative information. Quantitative information means that there are 2 molecules of hydrogen are reacting with 1 molecule of oxygen gas, and they are producing 2 molecules of water. So this is the completely balanced equation, because 2 hydrogens on the reactant side, 2 multiplied by 2, 4 hydrogens on the reactant side and 4 hydrogen on product side, and 2 oxygen atoms on the reactant side and 2 oxygen on product side. So once we will calculate the mole level of interpretation, so there are 2 moles of hydrogen that is reacting with 1 mole of water, which is producing 2 moles of water molecule. And if we have to find out the gram quantities, so there are 4 gram of hydrogen, because total atom are 4, are reacting with 32 gram of oxygen gas. They are producing 36 gram of water. So the coefficient in the balance equation shows these coefficient are the first number rather than subscript are the small number which are after the element. So coefficient in the balance equation shows the relative number of molecules of the reactant and product, and relative number of moles of reactants and product, which can be converted to mass. And in further in stoichiometric calculation, this is another example for if we know the gram quantity of a substance A, we use the molar mass of a substance A to convert into mole, and if we know the use coefficient from the balance equation to find out the mole of substance B, and then use molar mass of substance B to find out the gram amount of substance B. So we have already seen in the this chapter how to convert the gram to mole or mole to gram. The very simple formula will be small n, which is number of moles, is equal to small w, is gram, and divided by molar mass. So use this formula, which is very handy, and if you know the weight of in the gram or molar mass, gram per mole, then you calculate the number of moles. Or you can also use this if you want to calculate the gram quantity, then multiplied by number of moles multiplied by molar mass of that element or compound. So the new calculation is how to compare two different material using the molar ratio of balance equation, and then the mole ratio come from the coefficient in the balance equation. So here in example, if we how many grams of water can be produced from 1 gram of glucose. So this is 1 gram of here is the balance equation is written for glucose is solid. When burned in 6 mole of oxygen gas, it produces to 6 mole of carbon dioxide gas and 6 mole of water. So these coefficient is showing that number of moles. In the balance equation, these coefficients are showing the number of moles. Here we don't have any coefficient, it means this is have 1 mole. So there is a 1 gram of glucose to start, and the first step to convert it to moles. So first we have to convert the moles, how many moles of glucose will be in the 1 gram. So we have to use this conversion factor. Just remember, so moles of water will be equal to so before moving understanding, we should keep this balance equation in front of us. So moles of water will be equal to 1 gram of glucose, and we have to convert that how many. So 1 gram of glucose is equal to 1 mole of glucose divided by 180 gram of glucose. So this is the molar mass of glucose. So glucose will be cancelled out, and then so now we know that how many grams will be, how many moles will be in the 1 gram of glucose. And then we have to convert. So the new calculation is to convert mole of the substance of one substance in the equation of moles of another substance. Then the mole ratio come from the coefficient in the balance equation. Then we have to find out total number of moles of water from this 1 gram of glucose, which have how many number of moles. So once we know the number of moles of water, then we have to convert 1 gram using this further extend. Once we know the number of moles, then we have to convert the amount in the gram quantity by this conversion of molar mass of water divided by 1 mole of water. So in the last step, moles of water is converted in the gram of water, and this will give the answer we wanted. So you can do this each step separately, or you can do them in one calculation. Just keep doing together. So this is the one calculation in 1 gram. How many gram of water will come? So first we converted 1 gram of glucose into number of moles of glucose, and then from here number of moles of glucose, we find out how many total moles of the water will be there, and then from total number of moles of water we converted those moles into gram quantities. So this was another example of stoichiometric calculation, how to convert the gram quantities into mole or mole quantities into gram. Another topic is in the stoichiometry is the heat, but we are not going to study this heat in the detail here, because chapter 5 we will study in detail about the stoichiometry in heat in the stoichiometry.